All right, good evening, everybody. Welcome to the live Planet Fest on October 21st, 2020. My name is Stephen Hummel. I'm coming to you from a haunted telescope dome at McDonald Observatory. Of course, Halloween's just around the corner, right? So got to be festive. No, I'm just kidding. This is an infrared webcam, so I'm sitting in the dark. It's totally dark in this dome. I can't see the light that's shining on me, but you can. So I'm going to be operating this telescope you see behind me, showing you some high power views of 5 different objects tonight. And I'm joined tonight by Martinique Pautzke. Welcome, Martinique. Why don't you introduce yourself to everyone?
Yeah, hello everyone. Martinique Pautzke. I am on site at the McDonald Observatory right now in the residential area, streaming from my home, helping Stephen out here. We do want to call your attention to the chat. If you haven't said hello already, please do. That's a great place to ask questions throughout the program tonight. We have 3 moderators that are going to be in there to either answer your questions or set them aside for us. We might snag them in the middle of the program or try and touch on them at the very end. So please drop your questions in there. We're here to teach.
Yeah, thanks. And Kevin Mace asks how the skies are tonight. And we have great skies tonight. It was raining earlier. We had a thunderstorm about an hour ago. It just cleared off. And now we have totally clear skies again. Nice and cool, crisp October evening, 66 degrees, pretty low humidity. So yeah, it's a great evening. I'm going to talk a little bit about exactly where we are. Again, we're located at McDonald Observatory, and McDonald Observatory is a research facility of the University of Texas at Austin. So you can see 3 of our large telescopes there. I'm not in any of those. I am down at our visitors center. And if you've joined us for a program before, then this is going to be new to you. I'm not using the typical telescope we use for these live online programs. I am using what we call the Chow telescope, named after Dr. Alan Chow, who helped donate the system. It was also built with help and donations from Las Cumbres Observatory. And the telescope, which is right behind me, that's me. The telescope right behind me is a 20-inch telescope. So that means it's got an aperture 20 inches across, and it is mounted on a plane wave L500 mount. And it is very, very high tech, very sophisticated, and it's even got some custom upgrades to it as well to make the focus come out the side. So if you're a telescope nerd like I am, this is a really nice piece of kit. And tonight I've set it up specifically to observe planets. So it's going to have a lot of magnification, basically as much magnification as we reasonably can get out of a system like this. And the real limitation tonight in our views is not really going to be the telescope, but how stable the atmosphere is above us. We'll talk about that a little more in a bit. But one of the reasons we tried to schedule this Planet Fest, as we're calling it, for this time of year is because we have so many planets in the sky tonight at once, which we can observe in one given evening, basically, within an hour or so. So I'm going to hand it back to Martinique. And Martinique, why don't you tell us a little bit about what's so special about the arrangement of the planets in the sky right now?
Right now, a lot of the planets that we're looking at are very close to each other. You all are looking at Starry Night. Right now, it's a program that we use to model the sky where things are, and this is where things are right now. And you can see on there, I can use my mouse here, our moon is right there. It looks a little smaller than it actually looks if you were outside, but up and to the left a little bit, you can see there's Jupiter and Saturn and Pluto all right next to each other. Now, if you were out in a night sky, dark, where you could see up there, you would see Jupiter and Saturn. They're fairly large. They reflect a lot of light back at us. Pluto is much farther away and much smaller. So you would not see the speck of Pluto with your eyeball. You would need a telescope like Stephen's going to use tonight to help us pick that out. Now, you might notice that all the planets that we're seeing there, you might notice all these colored bands in the sky. Now, you wouldn't see that if you stepped out in your backyard and looked up. The program is showing us the orbits of those planets, and all those orbits are kind of lined up. And that is called the ecliptic. That line in the sky where all the planets go across, that traces the plane of our solar system. About 4.5 billion years ago, our solar system kind of formed out of a cloud of gases and dust. And as everything kind of came together, the conservation of angular momentum kind of forces it into a disk. And gravity starts to kind of clump things together. And out of that disk around the center, we got our sun. And the little clumpies along the outside of that little flat pizza became the planets. Looking up, then you're always going to see those planets along that plane. If you see a planet that's not along the ecliptic, you should be a little worried, a little bit. We'll talk about that little green line a little later. The first planet that we're going to be looking at tonight is Jupiter. Now, you'll notice that Jupiter, like I said, is there next to the moon, and it's going to be a big bright planet if you were to look outside in the sky. That's because it is a very large planet. Right now, it's about 930 million miles away. So all the light that you're seeing reflected from that is sunlight shining through space, reflecting off of Jupiter and back towards our eyes. So it's traveled a little ways. Jupiter is 480 million miles away. I have too many numbers written down. 480 million miles away, still pretty close, far. The orbital period of Jupiter is about 12 years. So to do a whole circle around the sun takes about 12 Earth years. And its day, right, a rotation, its day is about 10 hours long. And Stephen's going to show that to us.
All right, so here is our live view of Jupiter. There it is. That is live from the telescope behind me. And you can see Jupiter is kind of shimmering and wiggling around. So what you'll see is, what you're seeing is essentially heat and such rising off of the ground, as well as turbulence in the upper atmosphere, blurring and distorting our view. And that's kind of what we call, well, seeing. And so the seeing tonight is looking not so bad. We can see quite a few details. So the worst seeing means the more turbulence. Right now, we can see some details in Jupiter. So we've got two bands going across, two main bands at least, one here and another here. So you can, those are not very creatively named. Those are the north and south equatorial belts. But we also have the Great Red Spot. And the Great Red Spot is a famous feature on Jupiter. Right now, right on the limb. The telescope's getting buffeted by some wind right now. Yeah, that's a lot of wind. Oh boy. It's getting a little really windy in here, but it's still in there, huh? Just dancing around a little bit. The Great Red Spot is a giant storm. It's a giant cyclone, or actually rather an anti-cyclone on Jupiter. So it's kind of an inverted hurricane in a way. Hurricane is a low pressure system. This is a high pressure system. But regardless, it's enormous and you would not want to be in it. It's larger than the Earth. So the Earth could fit inside of the Great Red Spot right there. So Jupiter is, of course, massive. It's the most massive planet in our solar system at 318 times the mass of the Earth. That makes it 2.5 times the mass of all of the other planets in the solar system combined. So it's a true giant of a planet. What we also can see here is there are white areas. These are called zones. So we have bands and zones. These are different cloud features on Jupiter. So, of course, Jupiter is a gas giant. It's very famous for being a gas giant, which means it doesn't really have much of a surface in the conventional sense. If you were to dive down into those clouds, the pressure would rise and rise and rise until eventually you'd be crushed before you actually reach any kind of surface. There may be some kind of rocky or iron kind of core deep down in there which Jupiter sort of formed from, but we actually aren't entirely sure. But Jupiter is mostly made out of hydrogen, and that is about 90% hydrogen and about 10% helium. There's the same composition as the sun. So basically, if it kept adding a lot more mass to Jupiter, eventually it could form a star. You can kind of think of it as a star that never really grew up to become one. But another interesting thing that we can see tonight are the moons. So we've got 2 moons visible tonight. One is right here. You see it? Little tiny dot? We'll make
It's
it a little
there.
brighter. It's there. Let's make it brighter. Let's just increase the brightness. And you can see there's a dot there. And if we go pan out a little further, maybe we'll catch another one. We will probably see one more dot that I want to show you. There it is. So there's one more dot. So this is Io, and this is Europa, two of Jupiter's moons. Jupiter has a lot of moons. I wrote down how many because it keeps changing. 79 confirmed moons. And we keep finding more. There's almost certainly more than that. But those two are two of the four Galilean moons of Jupiter. So you can guess who discovered them. Galileo. But Io is a volcanic moon. I have a little picture here of Io. And it is the most volcanically active body in the entire solar system. It's around the same size as our moon. It is just slightly bigger at 2,200 miles across. And Io is so volcanically active because it's so close to Jupiter. It experiences tidal heating. Basically, Jupiter is so massive and Io is orbiting so close, one side of Io is getting tugged on more strongly than the other from Jupiter's gravitational pull. And that's stretching out the rocks, creating friction and heat, which gives rise to volcanoes. And you can kind of see in this picture, there's an orange spot. That is, in this picture, a recently erupted volcano called Prometheus. This was taken from the Galileo spacecraft, which got a lot of great shots of the moons. Europa, by contrast, is an icy moon, slightly smaller than our own moon. And Europa is known for being basically an ice world. It, too, experiences tidal friction and heating. So although it's covered in ice, you can see that, for one, there's no craters, which means that the surface has changed over time to erase any impact craters. And there's lots of cracks. And that's an indication that the ice is under a lot of stress. And Europa is considered to be a very likely place for life in our solar system outside of the Earth. Now, Venus made the news recently for some other possibilities, but before that, I would have said Europa was the best bet because it's likely there is a salty ocean underneath that layer of ice because of the friction from generated from Jupiter. It's enough to melt some of that water ice, and so there could be, in fact, a vast water ocean beneath the surface. In fact, some believe that it contains more liquid water than there is in all of Earth's oceans, just trapped under that ice. So I think we should go there and drill through that ice and see what we find. I think that would just be awesome. And in fact, there are some proposals to do something exactly like that. So let's take one last look at the live view of Jupiter before we move on. There it is. Great red spot and all. So Martinique, I'm going to hand it back to you, and you can talk a little bit about the next planet, Saturn.
So I've got a different view here in Starry Night. Now we are looking down at our solar system, and you can see that little bright dot in the middle is going to be our sun. And you can see Jupiter far, far out, what we just looked at, right? If we are, goodness, my pointer doesn't quite line up. If Earth is just over here, and we were, what, 430 million miles away from Jupiter, we're going to be looking a little bit farther out to Saturn here. Saturn's going to be the 930 million miles away from Earth right now. If I zoom up just a little bit more, there you go. You can see the name down there. Now, one thing that you might notice is if we were standing on Earth, most of you are probably sitting right now, standing on Earth looking towards Jupiter, you can kind of draw a straight line here. That's your line of sight. If you notice, your line of sight to Saturn is a very similar line. And that is why when you look up in the sky, you see Jupiter and Saturn very close to each other right now. Because right now, looking out into space across the plane of our solar system, they're very close in that line of sight. Now, right now, Saturn, like I said, 930 million miles away from us on Earth. Its orbital period is about 29.5 years. So it takes 29.5 years for Earth years for Saturn to go around the sun. And its day, its rotation, its day is only about 10.2 hours long. So a little faster than ours, a little faster spin. And I think if Stephen's ready, I'll pass it back.
Yeah, I've got a view of Saturn here. All right, so there is our live view of Saturn, my favorite planet. I think you can see why. It's famous for those rings for good reason. Now, Saturn is not the only planet with rings. The other gas giants, Jupiter, as well as the ice giants, Uranus and Neptune, also have rings. But Saturn's is the only ones that's obvious. And Saturn's rings are mostly made of chunks of ice. Most chunks no bigger than your fist. And there's just millions of these tiny little pieces in orbit around Saturn. And they form this beautiful ring system. And of course, ice is very reflective, so it's reflecting all of that sunlight back at us. But you can see that some of it isn't, because some of it is in the shadow of Saturn. So you can see clearly where that dark outline is. That's the shadow of Saturn cast upon the rings. You can also see that there is a line in the rings. This is known as the Cassini division. And it's really not a gap in the rings. It's just an area of less material. And there's less material there because of some of the moons in orbit around are creating essentially a resonance where those chunks of ice are either pulled into a main ring or swept up by the moon or kicked out. So there's kind of lanes essentially of traffic, and anything deviated from it will eventually be swept back in line by the gravitational influence of something else. So that's what keeps the rings nice and tidy. The rings are roughly 170,000 miles in diameter from edge to edge. For reference, the Earth to the Moon is about 220-ish thousand miles. But they are less than 100 feet thick in most places, and in some places just a few feet thick. So in sometimes we view Saturn edge on, and the rings appear to disappear because they're so thin we can't even see them anymore. Like Jupiter, Saturn is mostly made out of hydrogen and helium, and it's very large. Still not nearly as large as Jupiter, but the planet itself is 72,000 miles across. That's about 9 Earths across, and it has a volume of 108 Earths, but a mass of 95. So it's actually the least dense planet. It's big and puffy. It's not all that dense. Saturn currently is the champion in terms of the number of moons. There's some wind in here again. If I increase the brightness, we'll see some of those moons. There's one there and there and there. They're quite faint. But if we pan up over here, way up at the top, is Saturn's largest moon. This is Titan, and that's a good name. It's a big moon. That's why it's called Titan. Titan is actually the second largest moon of all the moons in the solar system. Jupiter's Ganymede takes the number 1 spot, but even so, it's still bigger than the planet Mercury. So if Titan were in orbit around the sun rather than in orbit around Saturn, it would definitely be classified as a planet. Titan is also the only other object in the entire solar system to have liquid flowing on its surface. Titan is a strange place, seen here from the Cassini spacecraft. At first, it looks like a big featureless orange blob, but that's because it has a very thick atmosphere. Its atmosphere is mostly made of nitrogen with some methane. And Titan is also the most distant object humankind has ever landed something on. Back in 2005, a probe hitched a ride on the Cassini spacecraft and detached. The probe was called Huygens. And here's a video of its descent. So Huygens was a small probe, kind of looked a little bit like a thick trash can. And this is a time lapse of the data it took as it fell down through Titan's thick atmosphere on a big parachute. And now as you speed forward, you'll begin to see the surface of Titan coming into focus. So I think this is amazing. At this time that this probe landed on Titan, it was over 1 billion miles from Earth. So that's the record of the most distant thing we've ever landed an object on. Of course, it was unmanned, but still, that's incredible. Titan has an interesting surface. It's mostly kind of or some rock, but also a lot of ice, as well as lakes of liquid methane. Here's some examples of the lakes. One of the largest, or sea as we call it, is Kraken Mare, and that's basically Kraken Sea. That's lakes of liquid methane. It's very cold on Titan. It's well over negative 270 degrees Fahrenheit. And so that's enough to keep the methane in a liquid form, but sometimes it evaporates or turns into a gas. The gas floats up, it hangs around in the atmosphere for a while before it condenses again, and it rains back down, refilling the lakes and streams and things. So it's a very dynamic object, Titan. Really fascinating little tiny world, basically, in itself. So let's go back to our live view here. There's another moon I want to highlight just briefly, and it is just about here, and we can't see it yet, but I will make it even brighter than it is, and we will. There it is. See this little dot? That is Enceladus, or as I like to call it, enchiladas. But I say that joke so much, I worry I'm actually going to just start calling it that and forget its real name. So anyway, Enceladus is its real name. So Titan's pretty big. Titan, again, is larger than our moon. It's bigger than Mercury, but Enceladus is very small. Enceladus is only about 300 miles in diameter. But Enceladus, despite its small size, is almost equally fascinating. Enceladus is very similar to Europa. It's kind of like a miniature Europa of Jupiter. But Enceladus is confirmed to have water in it. And we know this because the Cassini spacecraft a few years back noticed these geysers shooting out from the surface. So Enceladus is mostly ice, but there's pressure and some small source of heat within it, and it's forming these geysers shooting out through the cracks in the ice. And so those are plumes of water vapor streaming out into space and just kind of cast off into orbit around Saturn. So we know of water. We know that there's at least some liquid water, or at least water vapor, on Enceladus, which is extremely exciting. Now, that doesn't mean there's life. There's a lot more that we need to, figure out, and there's a lot of barriers to life developing there. But that's a pretty promising indicator. It's at least a good first step to figuring out if there is life there, as we know it anyway. So let's head back to our live view once more and kind of bring the exposure back down. Just have one last little glance here at Saturn. And you can see that there is actually a little band across it as well. So similar to Jupiter, it also has cloud bands across it. Very similar composition, just not as obvious as Jupiter's. Okay, but I'm going to hand it back now to Martinique to talk about our next object, Pluto.
Next, we will be looking at Pluto. Now, something funny happens when we're at the visitor center and we're giving presentations about all these different planets, and we start talking about Pluto. There's this big intake of air in the room because it's a really touchy subject for some people. Without being able to read your guys' body language, I'm a little nervous to take this on. Pluto is currently, if you can see it out there, the farthest thing out, that bright green orbit is Pluto. Pluto is about 3.1 billion miles away. It's really far away. Its orbital period, it takes 248 Earth years to go around the sun. And its one rotation takes about 6.4 Earth days. So slow spin. Pretty slow. Now, Pluto is at this point considered a dwarf planet. It was not kicked off the planet list. It didn't go anywhere. Nothing changed about Pluto itself. What happened was our technology changed. Over the last 100 years, we have created bigger and bigger telescopes, better and better tools and devices and instruments to see things out in space. And we started finding so many more things, and we started learning so much more about those things. And it got to the point where we really needed to figure out how we need to define these words better. Historically, in ages ago, the planets, planetes, were the wanderers in the sky, the bright-looking stars that moved around more than all of the other background stars that really didn't move much. So with better technology, we're finding more things that are wandering around. So if the word planet is something that orbits the sun, well, we're finding a lot more things that orbit the sun. The asteroid belt, for one, has a ton of little rocks orbiting the sun, and the few big ones. So we really had to start looking at what these words meant. And what they decided was that a planet, a classical planet, is in orbit around a star. In our case, it's in orbit around the sun, which Pluto is. It also has a sufficient enough mass to create hydrostatic equilibrium, which means it can kind of smush itself into a spherical shape, which Pluto is. The third thing is that it has cleared its orbit. As the Earth orbits around the sun, there's not a whole bunch of rocks and other chunks of ice and other stuff that sometimes, you know, kind of fling into us or fling out. We've cleared our orbit. Our space around the sun is pretty clean. Pluto has not done that. There's a lot of stuff still orbiting around in the orbit of Pluto. So that means that we decided it was not a classical planet. It is called a dwarf planet. And Pluto doesn't know that that happened. It does not hurt Pluto's feelings. I like to say that Pluto's the king of the dwarf planets. He's the first one that we found. And that's really exciting. This whole new word concept that people are so distraught about just means that we learn so much. We need more words. That's a badge of honor. That's awesome. That's a great thing for science. When we learn more, we have to change our words. We have to change our definitions. We have to change what we're doing when we learn more. Also, we have found that as planets orbit around the sun, we talked about that plane. Originally, when the solar system was forming, it kind of formed into that flat disk, and all the planets coalesced out of the matter along that disk, the plane that I called the pizza. If you take a little look here, Pluto doesn't quite sit on the pizza. At this point, they don't think that Pluto formed like the other classical planets did, out of the matter and dust orbiting around what was the beginnings of our sun. They think that Pluto was a captured Kuiper Belt object. So another thing to think about, there's more things past Pluto in the Kuiper Belt that are big enough to be seen and are maybe going to be dwarf planets instead of classical planets. These words. It's not a bad thing, right, Stephen? I know it's hard on people. People love Pluto.
Right, yeah, I think I like what you said. It's the king of the dwarf planets. I don't think of it as a demotion. But are you prepared to check it out? Let us know in the comments if you have seen Pluto before, because I'm willing to bet very, very few people have ever actually found it. But here it is. Aren't you blown away? So Pluto, of course, is not very photogenic, and a lot of amateur astronomers don't really bother looking at it because it's really just a dot. And figuring out which dot it is in the grand scheme of things in space and amongst all the other stars and dots is really difficult. The only real reason we know that this is a planet is because if you watch this long enough, over hours, it will kind of drift across the sky at a rate that's different than all the other stars, which tells us that it's not moving with the rate of the stars, and that was the real clue that it is a planet. But if you're like, oh, gee, you know, I was expecting more out of this. Well, here is the best that the view that the Hubble Space Telescope could do. So actually, these are two different sides of Pluto. If you look at at the top one, the top image, that's really what the raw data looked like. Yeah, it's not great. And that's what the Hubble Space Telescope, you've seen what it can do and other things. It's unbelievable. And it doesn't have to worry about the atmosphere blurring things. So the figures you see there are kind of computer-generated extrapolations from the data above. But so that's really the best it got. So we really didn't know all that much about Pluto until a spacecraft went there to check it out up close. So Pluto is, yeah, it's really far out there, billions of miles away. So it wasn't until the New Horizons spacecraft got up close that we actually got any decent detail to the pictures. And here's a very famous image from New Horizons. This version is true color. This is kind of what your eye would see if you were up close. There's some other images circulating around online which have the colors a little exaggerated for more effect, but this is pretty true color. Pluto is, well, it's an oddball. It's about 70% rock and 30% ice. So as a percentage of its mass, it's a lot of ice, but it's mostly frozen nitrogen rather than water. And these ices kind of form bedrock almost. So it's a really geologically interesting and unusual little dwarf planet or minor planet. It's also kind of weird because, like as you mentioned, its orbit is eccentric. It's not in a perfect circle around the sun like all the other planets, which means it has very strange seasons. Sometimes it gets very much closer to the sun than others. It's always far away, but relatively it gets closer to the sun and much further in its orbit, which make the seasons on Pluto extreme. And so a lot of that a lot of that ice may evaporate, sublimate, and turn to a gas or thaw, and then refreeze again. So it's very interesting. Pluto is tiny. It's about a little under 1,500 miles in diameter, which makes it significantly smaller than our own moon. But Pluto actually has moons of its own. It's got 5. One of them is particularly odd. The other 4 are very, very small, perhaps little fragments of a collision with something else long ago. But Pluto's largest moon, Charon, is significantly large compared to the mass of Pluto, such that as it goes around Pluto, the Pluto also is pulled by its gravity, and it wobbles around. So some actually argue that this is sort of a double minor planet system, since they're both orbiting each other. It's not clear really that Charon is directly orbiting Pluto itself, because really they're orbiting our common center of mass, or their barycenter. Also, the weird thing about Charon, that little moon, is that it doesn't really share a lot of characteristics of Pluto in terms of composition and chemical makeup, which is perhaps a clue that it was some other object, some other Kuiper Belt object that got caught in orbit around Pluto, or maybe rather than formed with it. There's a lot of things out there. Pluto is definitely not alone in the Kuiper Belt. There are many Kuiper Belt objects, or another way of saying it is a trans-Neptunian object, something in orbit beyond the orbit of Neptune, at least on average. Pluto is the largest, but there's another one called Eris, which is really close. It's almost as big as Pluto. So if you were to classify Pluto as a planet, then Eris and all of these other ones should definitely be one as well. There's over 200 of these confirmed ones. So if you did want to call Pluto a planet, we would have hundreds of planets in our solar system. And so that's kind of why it was reclassified as a dwarf planet or a minor planet, to kind of signify that it is something that's kind of different. It's in a different class. That's not necessarily worse, just different. Another analogy is it's like saying, a household cat is a feline, just like a lion is a feline. That doesn't mean the household cat isn't as good as a lion, or any other way of doing it. It's just different. But yeah, they got all sorts of weird names. I dare you to try to pronounce that one that starts with a Q down there. I'm not going to try. But yeah, they got some fun names pulled from all sorts of different mythologies and lores. All right, so Martinique, I'm going to hand it back to you now to talk about Neptune.
All right, back to our view here. Neptune is going to be the blue orbit that you see just inside of Pluto there. Neptune right now is about 2.7 billion miles away, so awfully far. Its orbital period is 165 years. So if you were born on Neptune, you would celebrate your first birthday 165 Earth years after you were born. Yeah, a poorly attended birthday party, I think. And the rotational period is 16 hours, so that's how long a day is for one rotation. A lot of times when people see maps, they're noticing that in many images, I can wiggle it around, you notice that Neptune and Pluto's orbits look like they overlap, and they get all worried, like, when is it going to hit? It's going to be this year, next year, in 10 years. They're not going to hit. Take a breath. Those orbits do not cross in a way where the two planets will ever hit each other. For every 3 orbits of Neptune, Pluto makes 2 orbits. And again, if you kind of wiggle it right, it's just never quite in the right way. So don't be so concerned about it. It's going to be okay there. You pull up these maps in the programs, and a lot of people shoot their hand up. They're like, "Wait a minute! How long does Pluto have?" It'll be just fine there. That's mostly what I've got for that one. I did want to comment on somebody's comment. If I scroll up a little bit, talking about Pluto and its classification. Teresa says that the State House of Representatives in New Mexico voted that Pluto is really a planet whenever it passes over the state of New Mexico. Now, I didn't fact check this, okay? But I think that's fabulous. I hope y'all celebrate it with parties and enchiladas because they're delicious. I just think that's wonderful. I also wanted to point out to y'all, when you're upset about these, 200 objects like Pluto that aren't planets, like, we only had to learn 9 planets. Kids now only have to learn 8. As the technology got better and better, my poor 2-year-old daughter would have to learn, like Stephen said, 200. And there's no telling how many more we're going to find. So it'd be a little rude, I think, for us to put that on kids these days. They have to learn a lot. We've learned a lot in science over the last, 20, 30 years here. Let's see here. I know that Stephen said that Neptune was, because it's so far away, it's a little bit harder to find on there, and you got to find a good center on the view for y'all. Now is a really good time for y'all to start dropping your questions down there. What happens is at the very, very end, we ask for questions, and we get about 7 million in the last 20 seconds, and we really can't get to any of them. So I don't know if y'all are holding on to them. Please don't. We've got 3 wonderful moderators in there ready to help you out. Now you're all vigorously typing. Pluto revolve in peace. Oh, someone did ask, how is it named that way? Pluto was named, there's a story that I've heard. So Lowell Observatory in Arizona first spotted Pluto, and they didn't know what to name it at first. And an 11-year-old girl in England heard of this discovery and told her dad or her grandpa that they should name it Pluto. That was a Roman god for the underworld, right? It went along with all the other gods. And I guess at the observatory, they picked that one. So none of the other planets were named by an 11-year-old girl. So that's pretty awesome. How you doing, Stephen? Ooh. All right, Stephen, if you're talking, we cannot hear you. Do that mic thing.
Yeah, I did the mic thing. There you go. Wow, I should learn by now. Anyway, Neptune, yeah, right there. So Neptune is obviously now the most distant planet, a large planet from the sun. And it's very far away. It took over 4 hours for the light to reach us from Neptune. And as you said, it takes 165 years for it to orbit the sun once. It is pretty big, not nearly as big as Saturn or Jupiter, but it's about almost 4 times larger than the Earth across, or about 30,000 miles. But at this distance, it's still very small. It's kind of a light blue, and you can see that there is another fainter dot right there, and I'll make it brighter so you can see that better. This faint little dot right there. So that is its largest moon, Triton. So we got Neptune, of course, got out of the sea, and Triton. It's keeping with the theme. But Neptune is about 80% ice and slush and other weird icy things, as well as about 20% gas and rock. It's got an atmosphere mostly of hydrogen and helium and some methane, and that methane is the source of its bluish color. But even so, we're not exactly sure why it is so blue. But the methane isn't really enough to account for it. And of course, way out there, it's very cold. It is well over negative 300 degrees, but it's not as cold as we would think. Neptune is unusually warm for its distance from the sun, and it's not entirely clear why, but some theories are because of its very strong magnetic field. The magnetic field of Neptune is 27 times more powerful than Earth's, and there could be an interaction between its magnetic field and material around it that's keeping the outer layer of Neptune hotter than we expect it to be. So it is not actually the coldest planet. It's the second coldest. The winds on Neptune are the windiest of any planet. It is over 1,200 miles per hour around the equator, almost supersonic winds, which is incredible. That it's so intense. Most people who have seen Neptune are familiar with a picture of Neptune that came from the Voyager 2 spacecraft, the only spacecraft to ever visit Neptune. And in this picture, there is the famous Great Dark Spot, similar to the Great Red Spot on Jupiter, but just dark. However, although the Great Red Spot on Jupiter has been around since as long as we've been observing Jupiter, the Great Dark Spot on Neptune was a temporary event that was only really there, we think, for a few years, and Voyager 2 just happened to visit it while it was going on, and it's now gone. Subsequent observations have found that it has disappeared. So it is basically featureless again. And ground-based telescopes have a very hard time actually resolving things like this. But this is a true color representation of Neptune. It is a nice shade of blue, kind of a sky blue. Other representations kind of darken it more or increase its saturation, but it's still very blue. But that little moon Triton. Triton's a very unusual moon. This is data from Voyager 2 as well. Triton is a lot like Pluto in many respects in terms of its size and composition. It's about the same size as Pluto, maybe slightly smaller. But its composition is mostly frozen nitrogen with rock and ice and things. But it also orbits around Neptune the wrong way around. They're called a retrograde orbit, opposite of all the other moons of Neptune. And again, I'll point out in the live view, it is right there. So the fact that it orbits around the wrong way, counter to what we expect, is a sign that it is probably a captured Kuiper Belt object, kind of like Pluto. It's basically a sibling of Pluto that got caught in orbit around Neptune. Because Neptune's so far from the sun, and it's pretty big, it has a large kind of domain where if something gets close, it's going to be gravitationally attracted to it. It's called its Hill sphere, and it's got the largest kind of domain area of influence of any planet because it's so far from the sun. Because, for instance, if you were here on Earth, you don't have to go all that far from Earth before the gravity of the sun takes over. The further you go from the sun, the less its effects are. So it's easy for objects to kind of be caught in orbit around Neptune, and it's probably the case that Triton is one such object, a Kuiper Belt object that got captured. So yeah, all right, that's Neptune and Triton. It's got other moons. It's got 14 of them, but the most of the rest are very, very small. So we're not really going to pick them out here. But all right, let's head on to our last object for the evening. And Martinique, we'll talk about Mars. Yes, we can see Mars.
Yes, George asked if we could see Mars, and I want to thank Bobby for letting him know that it's on the list. So Stephen's going to get that pointed at us. For us, there we go. This is back to starry night here. I've zoomed in a little bit more on those inner planets. That big red circle is going to be the orbit of Jupiter. So well inside of Jupiter. we have those inner planets. And right now, all right, good, just double checking. You notice in, let's see, the green orbit of Earth and that kind of brown orbit of Mars, how we're both kind of on the same side right now. We're close to each other in our orbits. Now, Earth takes 1 year to go around the sun. You probably knew that. Mars takes 2 Earth years to go around the sun. So as, let's see, I can speed this up here. As they're walking through their orbits, oh, that was way too fast. Let's try that again. I don't want to make y'all dizzy. As they're walking through their orbits, you'll see in the coming days, we're going to quickly walk away from Mars as it continues its orbit around the sun. So a word you might have heard recently, I'll jump back to right now, is called opposition. Just on the 13th, Mars reached opposition. And opposition means that when you draw a line here, my mouse, a line here through the sun, Earth, and Mars, once they're positioned to be in a line, we see from Earth, the sun, opposite side of Mars. So if you're looking at that picture here, pretend you're sitting on Earth. You should be. On the left, you'd have the sun, and straight across to the right, you have Mars. That's opposition. And that is the time of the year in our orbits where we are the closest to Mars, and it is the best time to see Mars. And lucky for us, we've got Stephen here. I first want to let you all know Mars right now is about 40 million miles away. I think at opposition, it was closer to 35 million miles. So y'all missed about 5 million miles for your equality. Its orbital period is 26 months, so just over 2 years. And its rotational period, its day, is just 24 hours and 37 minutes. So kind of Earth-like. That's why we get these movies like The Martian with Matt Damon. Stephen!
All right. Yeah, I got Mars in here, so let's have a look. There's Mars live. So yeah, Mars, very famous planet. About half the size of the Earth, or 4,200 miles diameter, and only 10% of the Earth's mass. So it's kind of a small planet. And it does have an atmosphere of about 95% carbon dioxide. That's not great for us, at least. And it's got 2 moons, which we're not going to see. The 2 moons are called Phobos and Deimos, and they are puny. Phobos is only 14 miles across, and Deimos is only 7.7 miles across. And they are captured asteroids, which probably aren't going to orbit Mars for very long before their orbits decay and maybe they crash in. But Mars, as you said, it is near opposition, which makes it a great time to observe it. And if you look at Mars around any other time, it's a very small, kind of uninteresting dot, but we can actually see a lot of surface details here. So one part that leaps out is this kind of pale area here, smooth area, in contrast to this darker region here. So this large smooth area is called Tharsis, and although it doesn't look like it, it is actually a large sort of smooth mountain area or plateau. This is the area where there are many large stratovolcanoes in Mars, including the tallest mountain on Mars, the tallest mountain in the solar system, at 72,000 feet. Well, what is it called? Oh, Olympus Mons, which is kind of around this region here, in that region. That area, although it doesn't look like it, is sort of one giant gradual slope up. And it's just kind of dusty and smooth. These mountains are not very jagged and sharp. They're very, very, very smooth. A slight gradient to them. The color of Mars comes mostly from rust. It is not as red as people often expect it to be, but they're kind of varying shades of rust. But there's a darker region down here, and those are from basaltic rocks, which we have here on Earth too, darker kind of cooled lava flows. However, Mars is not very geologically active today. It doesn't really have a lot of active volcanic activity. For a long time, it was thought it was totally dead, but we're kind of learning a little more, and maybe there is a little bit of active geologic features on Mars, but certainly no large erupting volcanoes. And the volcanoes that were once active on Mars were more like, say, Mount Hawaii's volcanoes rather than large eruptive ones. They're the kind that sort of gently oozed lava rather than exploded all at once. Not to say that they couldn't explode. But also visible is this tiny little spot here. This is the south pole of Mars, and that is ice, mostly CO2 or dry ice, maybe a tiny bit of water ice in there as well, but for the most part, dry ice. And it is kind of spring or transitioning to a warmer season on Mars, and so that ice cap shrank. And so if you were to look at images taken a month or two ago, the ice pack would have been bigger. But it actually changes with the seasons. And as it all sublimates, turns to gas, the gas kind of floats around and it forms clouds. And the clouds on Mars today don't look very striking. Here is a Hubble Space Telescope view that shows some of those clouds a little better, taken at a different season on Mars, where you can see the ice caps more obviously down there. But the wispy stuff are clouds. So it does have an atmosphere, although it's very, very thin compared to ours. Even in a howling wind on Mars, you wouldn't be knocked over. You may have seen like The Martian in the movie. There's a scene where there's a big dust storm and things are knocked over. The wind, it can be very fast, but because the atmosphere is so thin, it doesn't have enough force or momentum to really push you around enough to knock you over. But it can pick up dust and create large dust storms. That was the case a couple of years ago at opposition, and we had a really lousy view of Mars because the weather on Mars just wasn't clear. But it's clear today. Good weather here and good weather on Mars. Okay, so this is about where we're going to wrap up our program, but we're going to start taking some questions. We're going to try to get to as many questions as we can this evening. But we may not have time for all of them, so the moderators are going to try to answer some questions as well. But yeah, thank you so much for joining us for the live Planet Fest 2020. So yeah, let's hear from some of you guys. What do you guys think? Let's hear from you. All right. So we have a question. Adrian Crawford asks, why are the Hubble Space Telescope images of Pluto of a lower quality than the deep field images? Yeah, so if you've seen images from Hubble, most of the ones you've seen are invariably incredibly impressive. But it's kind of like aiming your camera lens at a mountain 10 miles away versus an ant 5 miles away. Basically, it's just a factor of scale. Pluto is small. It's really small. And all those galaxies and things you see are thousands, hundreds of thousands sometimes of light years across. True enormous things. So it's just a factor of scale, basically. All right. Martinique, do you have any questions you want to tackle?
Robbie asked how big the telescope is that we're using tonight. And our telescope right now, is that still a 20-inch, Stephen?
20 inches, yep, half a meter of aperture.
So at the Visitor Center, we have a number of different telescopes that we use just to entertain people and look at the wonders of the universe. And the Chow Telescope Dome that Stephen is in is actually, after the star party, is supposed to be used for real research. And we had a 24-inch telescope that was doing that, but they took it for some upgrades and some maintenance. So we got this 20-inch loner over there.
I think we're going to keep it though. I mean, they say it's a loaner, but I don't know. I don't think we're going to give it back. It's nice.
I mean, the shipping costs are probably not worth it. We should probably just keep it here. I mean, it would be a better idea.
Pry it from my hands. Yeah.
Yes, exactly. It's 20 inches. Everyone would love to have that problem.
Yeah. Got some other questions. Matt Waters, how is the image of Mars not as clear as Jupiter and Saturn with it being much closer? Yes, Mars is closer, but it's also a lot smaller. So the size of Mars in the image is about the same size as the body of Saturn minus the rings. So it's just a smaller planet, whereas those Jupiter and Saturn are larger. So even though they're further away, it kind of accounts for that. Also, Mars is relatively low in the sky at the moment. We're basically getting it as soon as we can. It's decently high enough. the lower you look, the more atmosphere you look through, and thus the more distortion you get from the air in front of us. So that's why it was a little more swimmy compared to Saturn, which was a little higher up.
I got another one here. Brandon asked if people live on site here. And at the McDonald Observatory, we do. We've got about 75 people that live here. I'm actually in my housing unit right now, the office. A lot of astronomers that visit here to use these telescopes really appreciate that, because if they run into a problem in the middle of the night, we have our maintenance staff, our observation support staff right here. It takes them 20 minutes to get up to the telescope, as opposed to 45-minute, 2-hour drive or something. So yes, people live right on site. The helpers, the astronomers, a ton of different people live here. Yeah, good question.
Gail asks, how many rings does Saturn have? Well, it's a tricky question. It's kind of like asking how many colors are in a rainbow, because they all just sort of blend seamlessly into another. So we divide the rings into main sets and alphabetize them. But the more you zoom in, the more you can kind of find smaller and smaller groups of rings. So it's not a question with a definite answer. But there's at least 3 main groups, A, B, and C rings, and then some subgroups between them. But yeah, it's just kind of you can endlessly divide them.
We also had a question about how do we know what these planets are made of? For example, how do we know that Neptune has methane gas? And a lot of that is done with spectroscopy, right? As the sunlight reflects off the planet, we kind of get a little fingerprint of the different elements that are in that light once we spread it apart through a prism. So that's one way that we do those things. I know Stephen also talked about once we sent New Horizons past those outer planets, we were able to learn a lot more. I don't know if that was still spectroscopy done out there, though. Yeah. All right.
Yeah.
Fabulous.
Bobby Burkholder asks, are the SpaceX satellites impacting y'all's research? So no doubt you've heard of the many ills of SpaceX satellites, Starlink satellites. They have not significantly impacted our research at the moment. We're looking into, specifically, I'm trying to look into how much of an issue they're going to be. In terms of astronomy in general, if the wider field of view your telescope has, the more likely it's going to be impacted. And certain kinds of science are more impacted than others. Specifically, if you do research on comets or asteroids, because you're more likely to need the telescope to observe in twilight before it's totally dark, because it's the only time your targets are available sometimes. And that's when the satellites are more visible. Also, radio astronomers are concerned because there are radio frequencies emitted by these satellites, which may impact us, especially if other constellations of satellites grow. So we're looking at it at the moment. We can't really say it's ruined our data or anything. We're still fully functional and continuing to do research. But if they put up thousands more, it may kind of shorten the usable amount of time in a night. It won't ruin all ground-based astronomy, but the kind of twilight hours and an hour after it gets dark, we may have to kind of try to work around them to some degree. Yeah. Your turn, Martinique.
There's just some great questions. I got to pick on this one. Stephen is our dark sky specialist, so there are some towns nearby, but they have ordinances in place. Many of them are very far away and very small. I know somebody commented our closest Walmart with the big blaring lights is an hour-and-a-half drive away. It is a long ways away. So we have just the space between us and a lot of people. The 7 counties surrounding us do have ordinances to keep lights pointed down or off if they can be at night. We always emphasize, though, astronomers don't want people unsafe. We just want smart lighting. Smart lighting is pointed down. It's covered. It uses the right wavelengths. Stephen, want to add anything?
Basically, it's about dark skies, not dark ground. The surrounding community, they keep their lights on the ground, and that's what makes us able to do research and able to see all these fantastic things in the sky. I think we got time for one more question. Let me see here. I gotta pick a good one. I'm gonna try to make it as good as I can.
Right?
I know, there's so many here. Can you see lights on the moon once in a while? So, in general, there aren't really any light sources on the moon, at least not permanently. So we wouldn't expect much. However, there are a few spots on the moon that are really more reflective than others, and so that they catch sunlight, and they appear to kind of stand out. And also, there can be meteors and things impacting the moon and causing a slight little flash or a blip, and we can pick those up. So sometimes you do see a small little flash or something of some tiny little piece of rock smacking into the moon and causing a small little explosion, which we can actually see, but it's very rare. You probably need a telescope or other equipment in order to see it. Okay, so that's going to wrap up for tonight. Thank you all so much for joining us. And thank you, Martinique, for co-hosting. Thank you to my moderators and everyone else working behind the scenes to make this program possible. All right.
Thank you.
Bye, y'all.
See y'all next time.